Welcome to another video on my Raspberry Pi 1 Model B+. Running Raspbian Linux and connected with network GPIO. So network cable, GPIO cable, as well as it is stacked with the Serial Pi Plus, including a serial cable and the Raspberry Pi camera for, in my case, or in this case, streaming video with some 4 seconds delay. Also capable of very high resolution video and pictures, and I've done that in the past. Through the band cable it is connected to this breadboard with with a lot of electronics and some fischertechnik. And in this video I want to go back to the origins where I started the whole thing, which in this case, well, not entirely the origin, but as you've seen in the recent videos, I have 2 chips. SPI, well, where that is not entirely accurate. It's an analog to digital converter using the SPI protocol, and over several wires, and then right there. Then I2C, which is correct because it controls the LEDs, and because they are both connected, still connected to this Raspberry Pi, I can of course still use them. Then last time I also kind of introduced the VNC, in this case via Android, and you can try to do nice things, but the keyboard is a little bit cumbersome. Let me try to start the yep, that works. It is a bit strange to do this. And as you can see, it doesn't work very smoothly, but so be it. And then, no, I don't want that. I just want the keyboard. So then I refer to here. Can I get something? Not really. A mouse, send text, input mode, whatever. Disconnect? No, not disconnect. More? What can there be more? Well, all of this. No. No. I certainly do not want that to happen. So how do I get that keyboard again? Well, for now that will have to do. And you see that lamp right here, which is visible from one angle, and from another angle it isn't. So be it. What I want to do is to compare these things, although they are very different circuits, very different protocols. I want to see if they can run together. Well, you can say of course they run together, but I have some wires to replace because these are coming from a different era where I had these cables in use for other things, so I can replace them. And then see if everything still works. And here I used to have two LDRs. Well, in the meantime I have some more, and I can use the fischertechnik LDR as well. So let's see if I can bring it back to the original state, which would be fun. So let's see how this all ends up. Alright, well, now we are at the screencast. This is the Raspberry Pi view with mirroring my hand here in the tablet. Also both circuits, and well, I should actually remove this thing which kept a bent cable in place, but no longer necessary. And that already shows a delay of 4 seconds, so it goes nice. Then is this the serial cable? Not this one. This one goes to the other Raspberry Pi. But well, this works. And let's go to the. Oh, it used to be full screen, high definition full screen, and I have no clue, still have no clue why it's no longer full screen. But I'm happy that it is not a very low resolution or whatever. Anyway, now something else. Okay, this is then the tablet that I showed with the opened terminal. Then this is, needless to say, the whole circuitry. Also oscilloscope, not connected, as you can see here, no probes. Why? Well, the point is, this one requires, for this experiment, it requires at least 2 probes. And I can show you, of course, on the oscilloscope, no problem with that. So, changing to I2C, which is this part, I2C. I2C has clock and data. And then for the resistors here, I can only use 2 more probes. You've seen that. So how about the rest? Well, this circuit, this one, is using SPI, and that has 4 signals. So when I check SPI, I have clock, data, when, and CS, chip select. And they're also called clock, data, MISO and MOSI, or MISO, MOSI. And yes, that adds up to 4. So I do either one or the other. Can't do both. So right now, let me leave that for now. Going to the coder. It took a while before I knew which one I had to do, which one I had to take. But here are the 2 source codes. So this one is for the SPI, for this one, and this one, most recent, is for the lower one. And yes, this one is in Python, this one is in C. And can I run them both? I should be able to. But first, what I first mentioned as well, I am going to replace those wires, and I'm going to add the other LDR, because that's more fun when everything works. Alright, so right now in top of the screen the fischertechnik LDR, which I have connected in the parallel to this LDR. So this one is now parallel to this one, and I replaced some wires. Much more robust, and that should be working. I have also found the way to enter text in here, so in this window. However, that is not very easy. Apart from not very easy, it's also hard to see. So you can't see that I have written here Python. Which reminds me, can I enlarge the font? Preference maybe? Not really. Okay. So maybe I can use it, maybe not, but anyway, what I'm going to do is slide it a little bit down, because I'm now going to try for the first time in a long time to get this running. So let's see how this works out. Better to put it a bit up. Okay, and let's see. Alright, something seems to work. Now the question is, what does work? Does this change? I have an LDR1 and an LDR2. Oh, and I recall that they seemed to work the other way around. Now, what about covering up this one? Oh yeah, you immediately... is that a yes or no? Let go. Cover. Seems not to have a real effect. Neither does this one. Although now LDR2 says 0 or 1. Very low anyway. So I'm not quite sure on this one. And I should keep in mind that these lines here don't touch, because one is going to another resistor. So for now I do not entirely get it. Maybe time to put in some probes and see if things are really working, although the fact that one LDR says a full value says enough about the rest. LDR2 is 0 right now, letting go says 1. So that does say that it works. And the other one seems not to have a very big result. Okay, that's one thing. Now I would like to run them both. So let's do that. There we go. Okay, yeah, let's go sudo. And yep, here we have one. I could have, of course, put sudo in front of it, but and yes, you see here the thing going. Do I see it here? Oh yes. You see the LEDs here as well. So that's a nice idea. It's with delay, but you can see it. You can watch it. And why is it not doing anything at all? Oh right, I had removed everything from the print line. So if I go here and go down, I have removed all the screen output. So all you can see now is this one. And it only says, yeah, and now I really should put this up, put the camera down a bit. So I can press this as long as I like, but it doesn't work unless the whole counting has completed. And I may have to speed up, because waiting is a long time. So if I take this for 250 or this one down to 125, although this is not a thing, not important, this down to 250, then it goes really fast. But anyway, you can see it is counting, and you can see that this is working. So yeah, let me see if I can get some input here. Not via this way, so I have to do it this way, and then say space, okay, it does work. No, I need to do something else first. Send. Yeah, now can you see something or not? I can't, or barely. I see on screen here some 2 lines, and that means I'm now in the Python editor, which doesn't do it. which has no meaning in this video. Can I compile during the working of this script? I should be able to. So let me quit this, go here and say okay. Let me change this and that one to 250. No, not that one. That one thing. And some habits are hard to change. Right. Right. Now I need to scroll down and further to the compilation. Yeah, there it was. All right. And that should be right. Yes. And now go again. Right. Speeding up the whole thing. And I can go down to 125, going blazing fast. But I still have to find a way to check this, so I'm going to hook up the probes, because I want to see whatever happens, if something happens. I don't like that these values hardly change. Alright, two things. First, I have now rewired. I think the other one is barely visible here. LDR1, LDR1, LDR2, and I needed to rewire because according to this old schematics, yes, LDR, LED and ADC, and the chip is the ADC, of course, and there it says that the LDR2 from fischertechnik is connected to the potmeter. The LDR1 is connected to the solid resistor, which means that I had to rewire this one from here to here. And the screen output is immediately noticeable, although not very reliable, because now it says both 200 something. I cover one and nothing much happens. I cover this one. Right. Why would it change? Oh, now it did change. Yeah, temporarily. So, although I hope that things still are working with this one, I'm not quite sure why it doesn't do it like that. Yeah, let me hook up finally probes. And I did put the oscilloscope to slope. And now I hope that the wires are long enough. So one goes here. And one is supposed to go right. It doesn't matter where, here. And then I want to have a really nice signal. Oh, one wire is out. And now two wires are out. It doesn't matter which one goes where, because a resistor is bipolar. No, unipolar actually. Both are the same. Both sides are exactly the same. It would be nice if I could get both wires correct. One in, pressing down, and one in here. And of course, what Murphy is in place, whatever can go wrong will go wrong. One wire in here and the other wire in here. That is correct. So, and then I have to re-get access to the tablet. So, now they should be working. And I have limited time now. So, what does the oscilloscope say? Well, not much. Yellow probe, yes. And this probe says absolutely nothing. And okay, wait, that is because oh, that's a nice one. Let me switch them for the probe, because I have to measure it at this side. And now you can indeed see a very faint change here. So you see a clear change here, and a much, well, okay, this is a change here as well. Okay, why did I replace the wiring? Because I'm measuring here, this is the ground and this is the voltage side. So, and this is the green wire on the voltage side, so I have to measure here on the green side. So LDR2 says a low number, and this is strange because the values change, but if you look at the oscilloscope, oh right, now we get that again. The wire has gone. So, well, time is running out. I will try to fix it. There it goes. And then a probe. And you can see that it is a much lower signal than this one. Why that is, I don't know. There are different LDRs, obviously, so I expect that that is one of the reasons. Then going back here, it has sped up, but will I be in time for some nice things? I'm already past 30 minutes. Okay, I'll have to let it go. One final thing though. This one is, as I showed, being dealt with an onboard keyboard. Send text. Now the way to go out of this terminal usually is Ctrl D. However, Ctrl D doesn't work in this way. So I can send text, but it doesn't do a thing. So I did manage in the past to get some text in, but now it's not working. Not the way I like. Oops. And there one camera goes. Unfortunately, I have to start it again, but time is up. Alright, last segment of this video. So this is not working quite the way I had hoped. Rewiring here to make things working nicely. Speed up of this code, and yes, both run at the same time. Does it slow down more? I don't know, but it's a fun experiment anyway. Also with the RaspberryPi running and seeing everything. For now, thank you for watching. This requires more, of course, getting everything running at the same time. If you like this video, please subscribe to my channel. Give the video a thumbs up. Leave a comment or suggestion. Yeah, what can I say? You can also follow me on Twitter and Instagram. And please donate to make to show your support. Donating can via PayPal and Wired. You can also become a patron and have your name mentioned. More information, including the URL of my website, under this video. To be continued. Thanks for watching.